Boring logs, making soil descriptions that are complete, accurate, and effective. You're invited to participate in this powerful online educational experience dedicated to taking the mystery out of the subsurface. September 19th marks the date for this 90-minute live and interactive webinar. Every webinar by MidwestGeo Sciences Group includes free handouts consisting of the webinar slides and a record of attendance form. And continuing education units are available through Northern Illinois University. Let me tell you one reason we offer this important webinar. Here's an example. Have you ever inherited a project where your intuition tells you there's something wrong, maybe with the potentiometric surface map, or possibly your upgrading at water samples appear to be measuring downgrading impacts? Or have you had difficulty correlating buried sand units when you design a groundwater monitoring system, or understanding the physical properties in the subsurface, specifically understanding the distribution of hydraulic conductivity under your site? Well, most of us have had at least one or all these during our career, and when we discover one of these problems, we typically review past work such as geologic cross-sections and monitoring well locations to try to make sense of the subsurface relationships between geologic units and monitoring well screens. And sometimes we discover those correlations are fraught with uncertainty, so then we turn to the boring logs. How many times have you reviewed the boring logs containing virtually no meaningful information about the geology? Maybe they lend little or no clues about how subsurface units or physical properties correlate, plus perhaps the lack of standardized information call their credibility into question. Then where are we when we find our monitoring wells have virtually no basis for either vertical or lateral placement, and we discover we're coping with appreciable and unnecessary uncertainty at our site? Let's look at this problem a little bit different way. Let's consider the simple and common scenario shown on the screen. We have two boring logs, boring B1 and boring B2. Each show lean clay as shown with the soil classification symbol of CL based on the Unified Soil Classification System. Boring B1 also shows an interval classified as poorly graded sand as SP here, and boring 2 shows two intervals classified as poorly graded sand, SP, shown here. If our job is to monitor and create a potentiometric surface map from this buried sand body, the question we must ask ourselves is, does sand body A correlate to sand body 1? Does sand body A correlate to sand body 2? Maybe neither correlate, or both. How do we know? Maybe it helps if the precise soil classification matches from boring to boring. For example, what if we change the classification in boring B2 from SP to SW? Does that help us correlate SP of sand body A to the SP of sand body 2? Despite this scenario and the common approach to correlate soil classifications, this is totally a bogus approach. Correlating soil classifications is not the same as correlating geologic units. This 90-minute webinar illustrates in very simple terms what's needed to take the mystery out of the subsurface. It does not require impossible training or rubbing a rabbit's foot to make this simple correlation possible in the field every time. Yes, this approach for a meaningful correlation can be simply done in the field with confidence and be defendable and repeatable from person to person. Learn what descriptive elements are necessary to make your boring logs accurate, complete, and effective. It's not a mystery to take a mystery out of the subsurface. It simply requires a basic perspective about what's needed on our boring logs and why. What's the price of poor boring logs? Well, it forces us to make best guesses from insufficient information. Groundwater monitoring systems, excavation depths, foundation designs, and remediation approach are often based on boring logs that don't do their job. It forces us to cope with uncertainty. Boring log information often lacks geologic context to create meaningful correlations from boring to boring, and also fails to help us understand the distribution of physical properties such as hydraulic conductivity in the subsurface. And unfortunately, it forces us to question the credibility of not only the boring logs, but also project management, staff competency, corporate standards, and personal performance. But they fail to achieve their primary objective, which is to take the mystery out of the subsurface. Now, there are some reasons why our industry faces challenges, and here are some of those problems. There's confusion with multiple definitions and systems. Sometimes there's confusion in different procedures between different systems, between the Unified Soil Classification System and other soil classification methods. Sometimes there's confusion in usage between terminology and application. For example, crossover terms between geology and engineering, such as the word graded. Benefits of good boring logs create reliable project outcomes. They provide reliable and producible context for understanding the distribution of physical properties, including the important relationship of hydraulic conductivity at our site. They yield critical information about when aquifers and aquatards are not identified solely by their grain size. Reliable boring logs are money wisely spent. Plus, they have a lasting usefulness past the duration of the immediate project. And sometimes they can be used for business development purposes to showcase our company's expertise. And of course, they show our personal achievement and pride, but most importantly, again, they achieve the primary objective by taking the mystery out of the subsurface. The webinar instructor is Dr. Tim Kemmis, who has been teaching geologists, engineers, and soil scientists and environmental scientists about unraveling subsurface complexities for more than 20 years. Tim is internationally recognized for his research work in sedimentary depositional environments and his large-scale project work as a consultant. And because Tim's unique perspective from both his research and consulting experience, he's assembled a practical and applied process for subsurface characterization that begins with accurate and complete soil descriptions. He's a co-founder of MidwestGeo Sciences Group and a co-author of the field guide for the soil and stratigraphic analysis, which is free with each registration for this webinar. Listen and learn during this 90-minute webinar, and your project outcomes will immediately have a positive impact, and so will your project budget. Register now at MidwestGeo.com.